Welcome to today's session on Azure ExpressRoute, focusing on designing for resiliency. Yes, this is what we are going to learn today. So, before we start, I believe you have seen the previous videos and you do have a proper understanding about ExpressRoute, what it is, what it provides, the architecture looks like, right? So just to revise, if I have to explain or ask you again what is ExpressRoute, you can simply say it's a service, it's an Azure service that provides private, high throughput, and low latency connection. What it is private, high throughput, and low latency connection between your on premises and Azure. That's what it is, right? So this is what the ExpressRoute is. What are the benefits, why we use it, what all things we get? We have already discussed in our previous video. You can simply go and check those out. So for now, let's start understanding few things like reliability, resiliency, and availability. Why are we doing this? Because we have to understand the designing of resiliency. In order to understand this, we need to understand few things. And these things are really very important, which will help you everywhere in the architecture of cloud, not just Azure. So we need to understand these terms first. Reliability, right? As the word says, it is more or less, not more or less, it is exactly the same thing. Like we say, he is a reliable friend, or we can rely on this. So reliability refers to the system's ability to function correctly and consistently over time. So reliability is system's ability to function correctly and consistently, right? This is what the reliability is. Now, the second term that we need to understand is resiliency, right? What is resiliency? It's about preventing failures and recovering swiftly when they occur, right? So the proper planning of getting out of the failures if it happens. First, plan to prevent, then recover, right? And the third is availability. Now, there these terms reveal themselves. It's in availability means your applications and services are accessible when needed. Accessible when needed. All right. In the context of ExpressRoute, designing for resiliency means creating a network architecture that minimizes downtime and maintains continuous connectivity even in the face of unexpected issues, right? So all these things will help us achieving a resilient architecture of ExpressRoute. All right, so let's get started. We already know, if you remember the architecture we have created, if I'll show you, if you remember, there was on premises, there was Azure, right? Azure, and there was a Azure backbone, remember? Yes. And there was Microsoft Azure routers, right? Let's suppose this is here, Azure router. There was a service provider routers, or service provider Azure router, and the customer's router, right? In simple terms, this Each express route circuit consists of two connections to two Microsoft Edge or Enterprise Edge routers at an express route location that we have already talked about. From here, there would be two connections. For example, one connection here, and this is another connection like this. Active. Okay. All right. All right. Don't do this. Like this. Two connections to two Microsoft Enterprise Edge. All right, now see, this is Microsoft Edge location, and there are two primary connections. One primary connection and another one is secondary connection. There is two connections built to the partner edge. Right. If I'll take you to this, that's fine. Let me take you to the resiliency. Whenever we create express route circuit, if I come here under home, okay, all right, we were already there. So if we type here express route circuit, you'll get this express route circuits. You click on it, you click on create express route circuit. In the very first configuration page, you will find my account is disabled as of now, but that's fine. Resiliency. The option resiliency, which says maximum high resiliency and standard resiliency. So we need to understand these three aspects of the express route circuit. Standard resiliency is there is one express route circuit which has two edge routers and two links are connected. It is the same that we have seen here. This is the standard one. However, you can also enhance it, right? In standard, we have only single circuit with two connections at one site. That is important. It is active setup, which allows failover between the two connections. And if the entire site experience a failure, connectivity to Azure could be lost. So site is the ultimate blast. If something happens to the site, it will be down, right? So it is suitable for non-critical workloads where minimal resiliency is acceptable. But what if we want it to be redundant, even the site goes down, right? In that situation, you need to choose different resiliency. For example, if I choose high resiliency, it is a metro model offering resiliency across distinct edge locations. Now, under standard resiliency, it is the same location. High resiliency, we have a express route metro circuit, peer location 1 and peer location 2. If one side goes down, the other side will take the load. So high resiliency, a single circuit split across two sites within the same metropolitan area. It is not like two edge at location 1 and two edge at location 2. No, the express route consists of two edge routers, making it active, highly available pipe. But in this situation, there is one edge router at location 1, another one is location 2. Still, we have two active, not more than two. It's not like four. We have two connection at location 1 and two connection at location 2. No, it is a single circuit split across two sites within the same area or site, same metropolitan area, let's call it, right? So it is again highly available, but now the site goes down, this site will take over, so it is redundant to the site. If we are running uh, you know operations where maximum uptime is essential, then we have to think for the maximum resiliency. However, this one is ideal for business critical workloads requiring enhanced resiliency. And when it offers better protection than standard resiliency, it's still within the same metro area, right? Uh, let's check the maximum resiliency. Now, in that situation, you can see there are four tunnels, right? One at the circuit one, we have both router and another location. There was the same metropolitan area, same metro area, but in maximum resiliency, We have two separate circuit across two distinct locations. Now these locations are totally distinct. It eliminates any single point of failure within Microsoft network path and ensures the highest level of resiliency suitable for mission critical applications, right? So this is what the resiliency is all about. Now there are certain things that we should keep in mind to design enhanced resiliency, because this circuit is connected to the gateway from where we actually create the connections, right? So the things that uh, we should be considering, so that it, because if any there would be any point of failure which is single point of failure or not redundant, then it does not matter if the express route is redundant, because ultimately if gateway goes down, it does not work, right? So we need to deploy zone redundant gateways, right? Here we need to utilize Azure's availability zones by deploying ExpressRoute VNet gateways across multiple zones within a region. This setup protects against zone level failures, right? So we need to make each and every component which is part of this entire architecture resilient. Still now we were talking about the express route circuit resiliency. Now we are talking about the design considerations for the entire resilient connectivity. Then we have to establish express route circuit in a multiple peering location and regions that we have already seen. So choose uh, correct resiliency as per the requirement, and when you create circuit, we have three kind of resiliency there. Now we need to ensure multiple paths between your on-premises edge and the peering locations. This can be achieved by using different service providers or routing through alternative peering location, reducing the risk of a single point of failure, right? And there is something very important, which is we need to enable BFD, which is bi-directional forwarding detection, right? We need to enable this. We need to configure BFD over express route to accelerate link failure detection. To accelerate link failure detection. Link failure detection. This is what it will do. And it will allow for a quicker failover and minimizing the downtime. If you're wondering what is BFD, so BFD is bidirectional forwarding detection. It's a lightweight protocol. What it is? It is a lightweight protocol. Lightweight protocol. Right. So what we're gonna do with this? It's a lightweight protocol which will help us to detect link failures much faster than the traditional routing protocol like BGP. So this link failure detection would be super fast as compared to the BGP. By enabling BFD, we can detect failures within milliseconds instead of waiting for standard BGP timers to expire, which can take up to 3 minutes by default. And why we need that? Because of this failover occurs. Since ExpressRoute relies on BGP, which is Border Gateway Protocol, for route advertisement and failover. To whom ExpressRoute depends? BGP. BGP is Border Gateway Protocol, right? For what? For route advertisement and failover. Now, BFD ensures that if failover occurs in the physical path, BGP is immediately informed and can fail over to a secondary link or express route circuit without unnecessary delays, because this is advertising the route, exchanging the route. As soon as one is down, this BFD will let the BGP know we have to publish or advertise route there, right? So that's how it's done. So we need to be aware of that. Now, if you're wondering where this BFD needs to be configured, that is on your on-premises routers or your provider edge routers. Azure side, Microsoft automatically enables BFD on its edge routers or for private and Microsoft, both kind of pairings. You do not need to enable BFD explicitly in Azure, but you need to be aware from the on-premises perspective. And there are certain things that we should also consider for this, which is monitoring. Now, all these things that we learned at the beginning, reliability, resilience, availability, are coming here. Now, monitoring will help us make it reliable. As soon as it goes down, we'll get to know and we'll make sure that it will come up as soon as possible. Resilient, right? So as a baseline, we recommend configuring network insights within Azure Monitor, right? You can utilize network insight within Azure Monitor to view all express route circuit metrics, including express route direct and global reach. So you could use network insights. Just enable that. And ExpressRoute uses Azure Service Health, which is there for all the Azure resources, Azure Service Health by default. And ExpressRoute uses it to notify you for planned and upcoming maintenances. Right. So with Service Health, you can view planned and past maintenance in the Azure portal along with configuring alerts and notification that best suit your needs. So it should configure that also. Now, you should also set up monitoring using Azure Monitor for Gateway for the availability of gateway, performance, and scalability. Right. So we also need to enable monitoring for gateway. Why? Because all the components you want to be up and running to make it available when we need it. Right. Now, there is something which is absolutely important and we should be aware of this, which is connection monitor. Connection monitor. Now, Connection Monitor is a cloud-based network monitoring solution that monitors connectivity between Azure cloud deployments and on-premises locations. Whatever locations that we are planning to connect, branch offices, main offices, headquarters, whatever it is. So Connection Monitor is an agent-based solution. It is an agent-based solution. Okay. And monitoring agents are installed on multiple servers, both on-prem and in Azure. If we go with this solution, we must go with this solution. Now, when we deploy agent on on-premises server and Azure server, the agents communicate with each other through and all right, let me do with each other by sending TCP handshakes or handshake packets. The communication between agent allows Azure to map the network topology and path the traffic could take, right? So that's how it will help you monitoring the connection. And with connection monitor for ExpressRoute, we can monitor loss and latency across various VNet and set alerts because it will have all the information because agents are talking to each other. So if we enable this on ExpressRoute, we can easily monitor loss and latency across various virtual networks. We can monitor all paths, including redundant paths on the network. It will help us troubleshoot transient and point in time network issues that are difficult to replicate. So it is recommended that we should use connection monitor. Now, this is all about ExpressRoute designing for resiliency, but there must be certain things that we should be doing on premises because this is all from the Azure perspective. Now, if we go to the this customer edge is involved, on premises network is involved, right? So if you opt for high or maximum resiliency, your on premises network must support redundancy first of all, right? You should deploy two separate routers firewalls to establish connection to both express route circuits. And these routers should be configured in active mode to allow automatic failover and load balancing, right? We need each and every component to be highly available or resilient. Now, we should ensure like BGP is properly configured on your on-premises routers, right? Because each express route circuit requires separate BGP sessions, one per peering. So your partner should be aware of that. And the service key is essential when setting up an express route circuit. Once we create the circuit, like if I'll go with this information, provide the region, circuit name, port type, through provider SKU and all, it will also give us the service key. We should share the service key with the provider. If you are working with the express route provider, we need to share this key with the provider. Only then they will be aware like what to do, where to do, where our this is circuit is. And we need to ensure that our provider is not using the same physical fiber paths for both express route circuit for maximum resiliency, because it has two different locations. We want them to be act accordingly so that it would be highly resilient. All right, then designing Azure Express Route for resiliency involves thoughtful planning and implementation of best practices to ensure continuous and reliable connectivity. By understanding the different resiliency models and following recommended design strategies, you can build a robust network architecture that supports your organization needs. Thank you for joining today's session. I hope you learned something new today.